The topic is Introduction to Integers. The objectives in this topic are represent real-life situations with integers, graph integers on a number line, compare integers, find the absolute value of a number, and find the opposite of a number. Finally, we will read bar graphs containing integers. So now we're going to introduce negative numbers. Numbers greater than 0 are called positive numbers. Numbers less than 0 are called negative numbers. 0 is in the center. This is a number line. Now, this number line is written in the usual way we see it, with 0 in the center, negatives to the left, negatives or positives to the right. But 0 doesn't always have to be in the center. Because a number line has this arrow on the left and this arrow on the right, that means that it goes left forever and ever and ever. It goes right forever and ever and ever. And any portion of the number line is a number line. So maybe 5 is in the center with 6, 7, 8 to the right and 4, 3, 2 to the left. But there'll be this left arrow indicating that everything to the left exists on the number line, all the way through the idea of negative infinity. On the right, everything after 6, 7, 8, 9, 10, all the way up through the idea of positive infinity, or up forever and ever and ever, never stopping. When we have a minus sign in front of the 3, that indicates negative 3. If we have just the number 3 or a plus in front of the 3, those both indicate positive 3. Negative 3 is on the left side of the number line, to the left of 0. Positive 3 is to the right of 0 on the number line. The number 0 itself is neither positive nor negative. The world's deepest bat colony spends each winter in a New York zinc mine at a depth of 3,805 feet. Represent this position with an integer. So we have some keywords here. Deepest and at a depth of indicate that we are below sea level. We're below the ground. Ground would be 0 feet. So the integer that represents a depth of 3,805 feet would be negative 3,805. The graph of negative 5 is to the left of negative 3. So negative 5 is less than negative 3. Less than, left of. You can keep that straight by remembering that. And we write that as negative 5, and this is the symbol for is less than negative 3. You can imagine that the open V is the mouth of Pac-Man. Pac-Man will always eat the larger number. So the mouth is always facing the larger number. We can also write negative 3 is greater than negative 5, since negative 3 is to the right of negative 5. So let's take a look at this on the number line. Negative 5, left of negative 3, negative 5 less than negative 3. Negative 3, right of negative 5, negative 3 greater than negative 5. Why is this a good example to look at? Well, because we know that on the positive side of things, 3 is less than 5. But on the negative side of things, that's kind of swapped around. The number with the 5, the negative 5, is actually less than the number with the 3, the negative 3. So things kind of work the opposite way on the negative side than they do on the positive side. And a way to keep things straight is always left of is less than. We compare integers just as we compare whole numbers. For any two numbers graphed on a number line, the number to the right is the greater number, and the number to the left is the smaller number. The symbol that means is less than kind of looks like an L. At least it looks more like an L than the backwards L that means is greater than. So left of, less than, looks like an L. Everything else is greater than. Right of doesn't look like an L. Greater than. So we're going to insert less than or greater than between each pair of numbers to make a true statement. For -6 and +3, -6 is to the left of 3 on the number line. Left of is less than. 0 is to the right of -7/8. 0 is to the right of anything negative. We don't know what a fraction is yet, but that's a fraction. Since 0 is to the right of negative numbers, 0 is greater than negative numbers. And we don't know what decimals are yet, but we have -3.6 and -4.2. Let's just imagine that was -3 and -4. Well, -3 is to the right of -4. So this would be greater than. 3 would be less than 4, but -3 is greater than -4. Next, let's discuss the idea of absolute value. The absolute value of a number is the number's distance from 0 on the number line. The symbol for absolute value is this vertical bar to the left and to the right of the number. So the absolute value of 2 is 2 because the distance from 0 is 2, and distance is always positive. The absolute value of -2 is 2 because -2 is 2 units from 0. Again, the distance from 0 is 2. Distance is always positive. So the absolute value notation just tells us to give the positive version. The absolute value of -8 is +8. The absolute value of +9, that's already positive, it's +9. The absolute value of -15, turn it positive, +15. And all of that is because of the distance from 0. Whether you're -8 or you're +8, you're 8 units from 0. Whether you're -9 or +9, you're 9 units from 0. Whether you're -15 or +15, you're 15 units from 0. So absolute value is just the positive. Now, we've mentioned that 0 is neither negative or positive. But we can say that the absolute value of 0 is 0. Why? Same reason the absolute value of -6 is +6. The absolute value of -6 is +6 because -6 is 6 units from 0. How far away from 0 is 0? Well, we're already there, so we're 0 from 0. The distance from 0 of 0 is 0. So absolute value is always positive unless it's 0. But it's absolutely never negative. This is kind of similar to the idea of opposite numbers. Opposite numbers have the same distance from zero. For instance, 5 and -5 are both 5 units from zero. We would say that 5 and -5 are opposites. 5 is the opposite of -5, and -5 is the opposite of +5. Just switch positive to negative to get the opposite. The opposite of 4 is -4, would be written as negative and then 4 in parentheses equals -4. This symbol, the minus symbol, is spoken as the opposite of. The opposite of 4 is -4. Likewise, the opposite of -4 is +4 would be written as negative parentheses -4 equals 4. The opposite of -4 is +4. In general, if we let A be a number, then the opposite of the opposite of a number is that number. In other words, we have this double negative property. The opposite of the opposite cancel each other out, and we're just left with A. So taking the opposite turns a negative into positive. Taking the opposite of that positive will turn it back negative. And remember that 0 is neither positive nor negative. Therefore, we just say the opposite of 0 is 0. So let's find the opposite of these numbers. The opposite of +14 is -14. The opposite of -3 is +3. And we see if we write that out, the opposite of -3, the two opposites cancel each other away, and we're just left with that +3. Switch positive to negative, switch negative to positive. Now let's do some mixed practice with opposites and absolute values. A says the opposite of -5. The opposite of -5 would be +5. B, we have a lot going on. We have an opposite and we have an absolute value. So B says the opposite of the absolute value of -8. The absolute value of -8 is +8, and the opposite of +8 is -8. So B is -8. C says the opposite of the absolute value of 3. The absolute value of 3 is 3. The opposite of 3 would be -3. So C is -3. Let's do an evaluation with absolute values. It doesn't change what we do. Let's evaluate the opposite of the absolute value of x. If x is -6, when we evaluate, we take the given value for x and we plug it in. I'm dating myself at this point, but it reminds me of the Glade commercials, the old Glade commercials. Plug it in, plug it in. The opposite of the absolute value of x would be the opposite of the absolute value of -6. We take that -6 and plug it in for x. The absolute value of -6 is +6. And then the opposite of +6 is -6. Next up, we're going to have a table problem, and let's see how we get this answer of Venus. Which planet has the highest average daytime surface temperature? So Mars through Neptune, Mars, Jupiter, Saturn, Uranus, Neptune, those are all negative temperatures. They won't be the highest when we have those positive temperatures for Mercury, Venus, and Earth. Mercury is positive 330, Venus is positive 867, Earth is positive 59. So Venus has the highest average daytime surface temperature. It is the tallest bar, the uppermost bar. And that is it for this topic.